Kernel density estimation is a mapping technique for visualizing hotspots of crime. KDE is available in many types of spatial analysis software and is popular due to its accuracy in hotspot identification and because of the good-looking maps the technique produces. KDE helps to identify clusters of crime. It's a technique that can be applied to any type of crime, including robbery, thefts, assaults, and house burglary. KDE requires data to be geographically referenced as point objects. That is, each crime record must contain geographic coordinates relating to where the crime took place, with these coordinates being used to create a point on a map, in a GIS or some other spatial analysis software, showing this location. KDE maps can be used to help identify where resources need to be targeted, such as police patrols. And further analysis of the crime patterns in the hotspots can help to better understand what is causing these clusters of crime to form. To produce a KDE map involves 3 key stages: the input of data for the chosen study area, selecting KDE parameter values, and choosing the thematic categories for displaying the results. The input data is the crime data for which you want to create a KDE map. This data must be in point object format. KDE parameter values include the cell size and the bandwidth size, the bandwidth also sometimes referred to as the search radius. When producing a KDE map, the technical process within the software starts by generating a cell matrix that covers the study area. Each cell needs to be of a specified size. Large cell sizes produce blocky looking maps, maps that do not have high resolution. Small cell sizes mean that the resolution of the map is much finer. The bandwidth size is the main parameter that influences the types of KDE output that is visualized, particularly in terms of the number of hotspots and the size of the hotspots. Large bandwidth sizes produces large hotspots, and small bandwidth sizes produces small hotspots. You don't want to make your bandwidth sizes too small, otherwise your hotspots will not be able to reveal any particular interesting patterns. Thematic categories or thematic classes refer to the groupings that are used for representing the distribution of different values in the KDE map output. For example, in the map shown here, 5 thematic categories were used to display the results ranging from low crime density to high crime density. Each thematic category relates to a numeric value, in this case the density of crime, and this is used as a separation point between that category and other thematic categories. Most GIS and spatial analysis software have tools for organizing KDE results into their different thematic categories. In the examples just shown, the natural breaks thematic categorization function was used to create the thematic groupings. Other thematic categorization functions are available and include equal ranges and standard deviation. Let's see a couple of other examples of KDE hotspot maps. This first map shows the distribution of robberies against pedestrians in the city of Joinville in Santa Catarina. The map was produced using 1 year of crime data, a cell size of 10 meters, and a bandwidth size of 250 meters. For this map, the thematic categories were created manually into some logical groupings. The second map shows the distribution of homicides across the municipality of São Gonçalo in the state of Rio de Janeiro. The map was produced using 1 year of crime data, a cell size of 50 meters, and a bandwidth of 1,000 meters. The thematic categories were produced using the natural breaks technique. Kernel density estimation is a useful technique for identifying hotspots of crime. It uses geographically referenced point data of crime records. It's quite easy to apply and is available in many spatial analysis software such as QGIS and ArcGIS.